All right, to prove part C, we're going to start by using what we proved in part B. So in part B, we proved this inequality, right? Okay, so first what we're going to do is take it out of the absolute value. So to take something out of the absolute value, right, we could say that like the first thing minus the second thing is less than or equal to m times e. Or we can flip them and say that the second thing minus the first thing less than or equal to m times e. So that's how we get it out of the absolute value. So we're going to call that step 1. Step 2, whatever I was subtracting on both sides, whatever I was subtracting on the left-hand side, I'm going to add it so that it's on the right-hand side. So now our inequalities look like this and this. Okay, so now I'm going to take the sup of the right-hand side. So the sup of this right here would be u of pf alpha prime. And the sup of this right here would be the u of pf alpha. So now our two inequalities look like this. And you have to take the sup of the right-hand side first, because by doing that, it's kind of like you're just doing this, right? And replacing it. So, if this is less than this, I could just cut out that middle piece and end up with these two statements. Okay, so that was step 3. Step 4, now we're going to take the sup of the left-hand side. So the sup of this right here would be the upper sum of pf alpha. The sup of this right here would be the upper sum of pf alpha prime. So now I'm going to take this piece and subtract them on both sides of the inequality. So I end up with this and this. And just like before, if I have the first thing minus the second thing is less than or equal to m times e, or the second thing minus the first thing less than or equal to m times e, instead of writing both of those inequalities, I can combine them into one absolute value inequality. So step 6 right here is one of the things that we wanted to prove in part C. In part C, we also want to prove the same statement but with the lower sums. So we're going to look back at our step 2 from above. So our step 2 from above were these two inequalities. Well, this was step 7. Okay, so before we were looking for the upper sum, so we took the sup. Now we're looking for the lower sums, so we're going to take the inf. So just like before where we had to take the sup of the right-hand side, now we have to take the inf of the left-hand side first. So the inf of this would be the lower sum of pf alpha. The inf of this would be the lower sum of pf alpha prime. And again, we have to do the left-hand side first because the inf would be like you were doing this, right? So then we could say that this is just lower than this and cut out the middle part altogether, and that's how we would get this. Okay, so now that we took the inf of the left-hand side, now we're going to take the inf of the right-hand side. So the inf of this would be L of pf alpha. Inf of this would be, the inf of this first one would be L of pf alpha prime. The inf of this second one would be the lower sum of pf alpha. So I'm going to move these two statements over to the other side of the inequality by subtracting. So I get lower sum of pf alpha minus the lower sum of pf alpha prime less than or equal to m times e. And the opposite, the lower sum of pf alpha prime minus the lower sum of pf alpha less than or equal to m times e. So instead of writing the two statements, I can combine them into one statement and say the absolute value of the lower sum of pf alpha minus the lower sum of pf alpha prime less than or equal to m times e. We've proved all of part A, all of part B, and all of part C, so we can finish our proof, which this was also written on the handout, but so now we have the upper interval of f d alpha equals the upper integral of f alpha prime dx, and the lower integral of f d alpha equals the lower interval of f alpha prime dx. So we can say that f is integrable on the closed interval a to b if and only if f alpha prime is integrable on the closed interval of ab.